Okay, good morning everyone once again. Now let us start the things which we have left out in the last lecture. Right? What we have isoperimetric problem. Correct? What is isoperimetric problem? For any extremization of an integral I, what are the things we have studied? The integral I, if you have, it is with say from x1 to x2 f of x y by dash dx. So this type of integrand will be extremum if what the conditions we have to find out dou I by dou alpha which is equal to 0. And hence we get the equation dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. For extremization of I, the integral must satisfy Euler-Lagrange's equation. Now, we are going to extend this idea to isoperimetric problem. I hope those who have attended the last lecture can come to know this. What is isoperimetric problem? It is nothing but the things that whatever the integral is going to we are going to extremize this. That means we are going to find out the extremum value of this. That is either a minima or maximum. For that, we are not having any restriction. But now in isoperimetric problem, we have one more restriction. What is that restriction? Is denoted by integral j within the limit say x1 to x2 g of x y y dash dx is equal to some constant, right? So for extremization of integral I, we should also find out the extremization of a j, or we should find out extremization of I under the condition of j. And this next conditions are, these are our boundary condition, y of x1 is y1, y of x2 is y2. Okay, so these are the things we have to study, that extremization of I should be considered under the condition of j. Okay, am I audible?
Yes, ma'am.
Now let us. I think we have started the things. I have drawn this image also, that for any 2 points P and Q, we should find out the correct path between point P and Q, right? But up to now we were having only one condition, but now there is extra condition. For that, we can now rename all the paths that start from P and ends to Q are now given by some another condition y of epsilon 1 epsilon 2, that will be y of x0 plus epsilon 1 eta 1 of x plus epsilon 2 eta 2 of x. Correct? Up to now we were writing about this as f y of x alpha is y of x0 plus alpha times eta of x. Correct? So up to now we have seen this y of x alpha, that means all the paths that starts from P and ends to Q, or all the paths passing from P to Q are given by this equation. This was true when we are having only one integral I and we have to find out the extrema of this. But now in this case we have to find out the extrema of integral I under the conditions of extrema of a integral j. Okay, so that's why we have used the two parameter epsilon 1 and epsilon 2 instead of using a simply alpha, right? Now again, if you knowing that, we have to use our basic lemma of calculus of variation to prove this result. So that's why we can now have epsilon, sorry, eta of xi should be equal to 0. Or you can now, you can say it as j also, because both I and j will be running from 1 to 2, because it is epsilon 1 epsilon 2 and here eta 1 eta 2, and values of x are x1 and x2, right? So these condition ensures that all the paths are passing through points P and Q. And I have shown you the example that where someone is coming from hostel to department itself, he or she can come through some another paths also, or she can come directly from hostel to our department, right? If we're not having a doubt in this case, let us go for finding the next one, right? I hope you come across this. I have renamed the new integral as I star plus lambda times j, where I is an integral and j is also one integral which is provided to us, right? These are the two things. Now, what will be corresponding function f star will be nothing but f plus lambda g. Okay, this is what your function f, which is in the integral I, and g is a function in the integral j. Okay, so in this way, we have found instead of finding the extrema of I under the condition of j, we can now find out the extrema of I star. It is equivalent to find out the extrema of I and j combinedly. Now directly we can find out the extrema of I star. I think I have given you a homework to find out the what is a Lagrange's multiplier, because here in this case we are going to use a Lagrange's multiplier method to find out the answer for this. I don't know how many of you done this homework, but still if you want, you can go to your BSc second year or third year books where you can see what is a Lagrange's multiplier method. Okay. Now we have to find out the extrema of a I star. Okay. Find out extrema of I and j combinedly, it is equivalent to find out the extrema of a I star. Right. Okay, now let me write down this I star is equals to integration of what is a function now? It is f star of, or you can write it as capital also. Let me write down here this one. F star of x, y dash, dx. Instead of having a function f, we have f star. That is, if you want to find out extreme of I star, we should find out the integration of this function. Now, instead of having a function f only, because now we are going to use a condition f plus lambda j, because here we have to find out extreme of I under the condition of j. So hence corresponding integrand we have to use f and g by using the Lagrange's multiplier method. Okay? Any doubt up to this?
No, ma'am.
Okay, if not, let me now find out the next thing what we have to do. Dou I star by dou alpha. Up to now we are finding dou I by dou alpha. Now, if you find dou I by dou alpha, we have to find out it is equals to 0, and then we can get our Euler-Lagrange's equation. But instead of having simply alpha, we have two parameters. So that's why we have to now differentiate with respect to epsilon I. Okay, this integration x1 to x2 as it is, because the integration is with respect to x and we are going to differentiate with respect to epsilon I. Okay. So for that, now first what we have to do, we have to differentiate f star with respect to x, then x with respect to epsilon I. Okay. Derivative of f star with respect to x and derivative of x with respect to epsilon I. Okay. Next, f star with respect to y and derivative of y with respect to epsilon I. Plus, what is the next term? F star. We have to find out a derivative of f star with respect to y dash, and derivative of y dash we have to find out with respect to epsilon I. Is it okay up to this? How to use?
Yes, ma'am.
Okay. Now what you have to do in the next step, we have to find out the values of these terms. Now if you think f star is not given to us, because f star is simply f and g. F and g are also not known to us. So we cannot find out the values of these terms. So for that, what will be the value of dou x by dou epsilon I? Because three times I have taken the Euler-Lagrange's theorem. Now I can expect what will be the value of dou x by dou epsilon I, dou y by dou epsilon I, dou y dash by dou epsilon I.
0, ma'am.
Correct. Why it is 0? Because there is no relation between x and epsilon I. This is summation I runs from 1 to 2. The same thing I have written in the form of a summation. These two terms we can write in the form of a summation that I have written here. Y of x0 plus summation over I runs from 1 to 2 epsilon I eta I of x. Okay. Now, okay, what is the next step? This term we have to equate it to 0. Okay. First derivative equated to 0, then we can find out the extreme now. Is equal to 0, this integration x1 to x2 as it is, right? What is the value of first term? It will be 0, right? Now the second term f star with respect to y, we have to keep it as it is. Now can anyone tell me what is the derivative of y with respect to epsilon I?
Eta I x.
Correct, eta I of x plus what is the derivative of f star with respect to y, f dash. It will be as it is. Now we have to find out the derivative of y dash with respect to epsilon I. Okay,
Eta I dash x.
y dash of x epsilon I will be nothing but y dash of x0 plus summation over I runs for 1 to epsilon I will be as it is. If you want to find out the derivative of y with respect to x, epsilon I is a constant, so we can keep it as it is. So it will be eta I dash of x. Now you have to find out the derivative of y dash with respect to epsilon I. There is no term of epsilon I here, it will be 0. There is a term of epsilon I here, derivative of y dash with respect to epsilon I, it will be 1. So what is a term remaining here? It will be eta I dash of x. Okay? Any doubt?
No, ma'am.
If not, let me know what is the next step is. This term we cannot do anything. We have to keep it as it is. Integration x1 to x2 f star with respect to y eta of x dx plus now we have to evaluate the integration of this term. Okay. So for that what we have to use is we have to use our integration by parts. So for that what will be the first term? We have to keep this as it is and integration of eta I dash of x. What will be integration of eta I dash of x? What is your eta I dash of x? It is nothing but derivative of eta with respect to x. Now if you are going to integrate with respect to x, derivative integration will get cancelled. We will have simply eta I of x minus the integration of derivative of first term, that is d by dx of f star with respect to y dash, right? And this integration of eta I of x dx. Okay. Now here we have to put up the limits also. What are the limits? X1 to x2. Now if you remember what was our second term, if you are going to use the conditions of uh, eta I of xi, if it is equals to 0,
0.
right? Why it is equal to 0? Because these condition ensures that all the paths are passing through points P and Q. So here we have written eta I of xj equal to 0, or you can write eta I of xi equal to 0 because both are running for 1 and 2. Values are given x1 and x2 because we are having 2 points. Eta I, that means we are having two conditions. Why? Because I and j, two integrals are given. So the second term will be 0, this term will be equal to 0, right? Minus what we have now, x1 to x2 d by dx of f star with respect to y dash eta I of x dx. Okay, now what are the terms we can take common? Integration with respect to x we can take common. Next is eta I of x we can take common. And hence now we can write the integration x1 to x2, right? What are the terms we remain inside? It will be f star with respect to y minus d by dx of f star with respect to y dash. And what is there outside the integration? The common terms are eta of x dx, which is equal to the 0. Okay. Again, now here we have to use a basic lemma of a calculus of variation. आठवते का basic lemma of calculus of variation? What was our lemma? The integration gx eta of
Eta
x
x
to
dx equal to
0
0.
on the condition eta 1 of x1, sorry, eta of x1 is equal to eta of x2 is equal to 0, which implies that g of x is equals to 0. What is
0.
g of x is any arbitrary function. So here we can use a basic lemma of calculus of variation. This is what your g of x and this is eta of x, which is equal to 0, and these conditions are also true in our case, and hence we can say g of x is 0. So now by using basic lemma of calculus of variation, I can write the next step that we have now found the new Lagrange's equations, Euler Lagrange's equation, so that f star is, what is a f star in this case is f plus lambda times d. Okay. So whatever the equation we have found for the first one, first version of Euler-Lagrange's equation, what is the change? Only it was f. But here this is f star. Why? Because we are having two integral. And for that f star is equals to f plus lambda g. F is integrand of I, g is an integrand of j. Okay.
Yes, ma'am.
Have you understood this? Because whatever the things we have studied for the first version, it is exactly same, but what is a change only? Instead of having a function f, we have f star. And what is your f star? F star is a f plus lambda g. Okay, so here we have completed our fourth version of a Euler-Lagrange's equation. Okay, now let us go for the examples. Mm, I hope it is not necessary to repeat the things, because whatever the thing we have done, it is already done for our Euler-Lagrange's theorem. Simply the change is f star and I star. Okay. Okay, let us go for the example. What is the example? Find the shape of a, actually this example was there in the set exam. Find the shape of the thread of a length L which lies on the x-axis so that it encloses the maximum area. Okay, let me write down the example. Up to then, you have to think. I don't know in which exam it was asked. Find the shape of thread of a length L which lies on x-axis so that it encloses maximum area. So that it encloses maximum. Think on this and tell me what is given to us and what we have to find out. Now in this case, we have to find out the maxima. काय दिलेलं आहे, काय प्रूव्ह करायचं आहे आपल्याला? Okay. Find the shape of a thread. That means we have to find out the shape of a thread of length L. Okay, we are provided with the thread of length L, right? Which lies on the x-axis so that it encloses the maximum area. Actually, I'm going to draw the image so that you will get directly the answer. Okay. Find the shape was the question, no? So it lies on the x-axis. So that's why we are not going to take the downward direction also. Okay. So here, shape of a thread L. Next, what is given to us? This is what your x-axis and this is y-axis. Find the shape of a thread L, which lies on the x-axis so that it encloses the maximum area. If anyone understood this, please can you explain? Okay. What do you have to do? Let y of x be a curve of length L. Okay. Find the shape was a question, no? So for that, let us assume that let y of x be a curve. Now after that, we have to find out what is the shape of this curve in the upper half plane. Okay, in the upper half plane. Why I have written upper half plane? Because in this case we have the thing is given to us that it is lies on the x-axis, lies on the x-axis. So hence we are not going to take the downward direction or a negative one. Lies on the upper half plane whose endpoints are given by. Let me take the endpoints as say x1 comma 0. As we are on the x-axis, the y coordinate is 0. Whose lie on the whose endpoints are. That means a thread we have to take and we have to convert it in the form of a circle, half circle rather. So the shape is already determined by using the figure itself. Y-axis be in the upper half plane and whose endpoints are x1 comma 0 and x2 comma 0. These are the endpoints of that thread of length L, and that is we have taken in the form of a one curve. And no doubt I am going to explain you how theoretically we are going to find out whether it is a half circle or not. Okay. So we know that the area bounded by the curve and x-axis is given by. Okay. We know that the area bounded by the curve and x-axis is given by. आठवते का कुणाला? Why we have written this equation? We know that area bounded by the curve and x-axis is given by. This is what your curve, na? And area bounded by the curve can be now find out with the integration from x1 to x2, and integration is with respect to x. Since we are in the upper half plane, hence now we have to find out the integration from x1 to x2 of a curve y of x. So hence we can write the area bounded by the curve and x-axis is given by. What is curve y of x? Y of x is made up of a length L. Is given by. Okay. Now we have the second condition also. What is the second condition? The curve has a some fixed length, that is L, under the condition that the length of the curve is constant. Okay. The next condition is given to us under the condition length of the function or length of the curve y of x is fixed out, which is a sum constant. And hence now we can write the integration x1 to x2, the whatever the area we have ds is constant. And hence we can write this ds is nothing but the thing we have already studied how to find out ds is 1 plus y dash square dx is some constant L. Is there any doubt up to this one?
No, ma'am.
मॅम स्ट्रेट लाईन का घेऊ शकत नाही आपण कर्वच का घ्यायचा
हा तेच आपल्याला प्रूव्ह करायचं आहे ना कर्वच का घ्यायचं म्हणून ऍक्च्युली ओके लेट मी आस्क यू वन क्वेश्चन okay here we have maximum area right what is your question if we can take a straight line can you find out the area of that a straight line
No, ma'am.
we cannot find out the area of a straight line. Na? If you want to find out area, you should be in 2D plane. And if you want to find out a volume, you should be in the 3D space. Is the idea clear? Those who have asked the question?
Yes, ma'am.
Okay. If it is true, now let us go. So we have to find out the area under the curve is given under these conditions. Okay. So, now what we have to do now our aim is to find out the curve which includes the maximum area. Okay, now our aim is to find out the curve which includes maximum area. Okay, so for that what we have to do now we have to now construct our functions. F star is equals to f plus lambda g. What is your function f given to us is y of x. No, this is your given function or curve y of x. Integrand of I plus lambda. What is g? Under root of 1 plus y dash square. Now, what is our integrand I? Sorry, I star will be I plus lambda j, which is equal to what is your I? Integrand I is nothing but integration of y of x, that is area bounded by the curve and x axis, and j is a condition which ensure that your length of that curve should be a fixed number, that is L. Okay. So now for extremization of I star, it is nothing but integration x1 to x2 f star of x, y dash dx. Okay. So let me now write down what is your f star. It is nothing but your y of x plus lambda integration 1 plus y dash of x square dx. Okay. Now for extremization of this I star, what should be the condition? The integrand f star must satisfy Euler-Lagrange's equation. Okay. Just now we have seen if I star is for extremization of I star, the integrand must satisfy this equation. F star with respect to y minus d by dx of f star with respect to y dash should be equal to 0. Okay. So hence now let me use that. What is your f star? Y plus under root of 1 plus y dash square. Sorry, here lambda is remaining. So let me now find out f star with respect to y minus d by dx of f star with respect to y dash is equal to 0. Okay, now you have to find out the answer of this. F star with respect to y, what will be the derivative?
1.
1. There is no term of y in the second term, so hence it will be 0. Minus d by dx of f star with respect to y dash. This lambda I have to keep as it is. Derivative of f star we have to find out with respect to y dash. There is no term of y dash here, so it will be 0. Now there is a term of y dash in the second term, and hence we can find out the derivative. It will be 1 upon 2 1 plus y dash square, and derivative of 1 plus y dash square will be nothing but 2 y dash, which is equals to 0. This 2 get cancelled. Now we can write this equation. What is this equation now? D by dx of lambda y dash divided by under root of 1 plus y dash square is equals to 1. Okay. Now we have to solve this equation so that we can find out the value of a y dash. Okay. So instead of doing the derivative, instead of finding the derivative, we will find out the integration. What will be the integration of this term? Integration is with respect to x, as well as the derivative we are going to take with respect to x. So you can write here, integrating the above equation, we get integration derivative get cancelled. We remains lambda y dash upon 1 plus y dash square is equals to, integration is with respect to x, so hence it is x plus some constant c1. Correct?
Yes, ma'am.
Yes, ma'am.
If you are having a doubt, let me write down here integration of this term. This is d by dx, the term integration derivative with respect to same variable. Integration of 1, that we can write integration dx will be x. Okay. What is the next step? It will be lambda y1 is equal to x plus c1 under root of 1 plus y dash square. Okay. Now let me square on both sides. Lambda square y dash square is equals to x plus c1 square. Square of this term will be simply 1 plus y dash square. Okay. Now what you have to do on the next step? We have to take the terms of y dash square outside. If I take y dash square outside, it will be remaining with lambda square here. And what is the term here? The multiply is here. It will be with negative sign, since we are going to take y dash square common. Okay, sorry, here it should be y dash. Y dash square, if you take common, here it will be lambda square minus x plus c1 square. Right? What is the next term? Remaining here, it will be x plus c1 square. Okay, x plus c1 bracket square into 1 plus x plus c1 bracket square into y dash square. So from here we have taken y dash square common, and here it is y dash square lambda square minus the term, we have kept it as it is. Okay. So what will be y dash square is equals to x plus c1 bracket square divided by lambda square minus x plus c1 square. Okay, so what will be the term after taking the square root on both sides? We get the resultant as y dash is equals to x plus c1. No doubt we can take plus or minus, because if you are going to square y dash square, it should be y dash should be equal to plus or minus. But since we are finding the area cannot be negative, hence we are writing it as positive. Okay. Have you understood up to this?
Yes, ma'am.
Okay. Now what is the next step? This y dash is nothing but your dy by dx. Now after integration of this equation with respect to x, what I get is simply y. In the exam you have to write down the steps. After integration of above equation with respect to x, we get integration will be simply integration derivative with respect to x. Hence we can get the term is y. So let me write down integration. Some limits. X plus c1 divided by under root of lambda square minus x plus c1 square. Integration is with respect to x plus some another constant c2, as we are going to integrate with not indefinite integral. Now what you have to do? You have to find out the value of this integration. Okay. Now can anyone tell me how to find out the value of this integration?
put x plus c1 is equal to something value.
X plus c1 is equal to, we can take it as, say, lambda sine theta. Okay, if we take x plus c1 is equal to some lambda sine theta, what will be dx? It will be lambda derivative of sine theta is cos theta d theta. Okay, now let me write down the values of these terms. X plus c1 is lambda sine theta divided by under root of, here lambda is there, so that's why we have substituted x plus c1 as lambda sine square sine theta. So here is lambda square minus x plus c1, its square will be lambda square sine square theta, and what is the value of a dx we have found is lambda cos theta d theta, which is equal to, if I take a lambda outside of integration, what will be the resultant term? Lambda square outside, if you take outside of a square root, it will be simply lambda, na? This lambda will get cancelled with this lambda square inside the square root. Barabar? Okay, what is there? If you take a lambda square outside, it will be 1 minus sine square theta. What is the value of 1 minus sine square theta?
Cos square theta.
Cos square theta. So as cos square theta is there and which is under the square root. So let me write down directly, it is as, sorry, it is theta, no? Here it is theta. Okay, 1 minus sine square theta is cos square theta. Taking square root, it will be cos. So this cos theta will get cancelled. What is the integration of this term? सांगा, lambda तर constant है. What is the integration of sin theta?
Minus cos theta.
Minus cos theta plus this term c2 as it is. And what is the term here? It is nothing but
Y.
okay. So what we get, y minus c2 is equals to minus lambda cos theta. What was your x? We have x plus c1 is equals to lambda sin theta. हे substitute केले होते ना आपण आता. X plus c1 is lambda sin theta. So what I get here, two equations I am getting. Y minus c2 is equal to minus lambda cos theta, and the second equation is x plus c1 is equals to lambda sin theta. Now if I take the square of both equation and if you are going to add, squaring and adding these two equations, what will be the resultant? X minus c1 square plus y minus c2 square is equals to, what will be the resultant? Lambda square sin square theta plus lambda square cos square theta. Sin square theta plus cos square theta will be simply 1, na? If I take a lambda square outside. So what is this equation?
Ma'am, x plus c1 है ना?
Oh sorry, x plus c1 it is. सांगा कुठली इक्वेशन है? तर आली.
Equation of a circle.
It is equation
Centered
of a
at
circle.
c1 and c2.
Centered at minus c1, no? What is the equation of a circle? X minus a bracket square plus y minus b bracket square is equals to r square. This is what an equation of a circle, right? So with center at a, b and radius is r. But here in this case x minus नहीं है ना, इधर प्लस है, तो इसलिए center at minus c1 c2 and the radius is lambda. Okay. Now, which is the equation of a circle with center minus c1 c2 and the radius lambda, which represent the equation of a circle in both x and y, right? But here the things is not completed. We have simply found the curve. Now what was our question? Okay. What is the question? Find the shape of a thread L of length L which lies on x-axis. So we have to find out what will be the case on x-axis. It is not in the downward direction, right? So what? Okay, let me write down the. Let me draw the image of that. Okay, what is this? This is an equation of a circle with center at minus C1 C2 ना मायनस कुठे येणार आहे निगेटिव्ह एक्स एक्सिसला येणार ना मायनस ओके सो हियर इट विल बी समवेअर मायनस and plus C2 so somewhere here you will get the circle correct but C1 is no doubt one constant so that's why now we can have this is what an equation of a circle with center at minus C1 C2 and radius is lambda. Okay, now which we are interested to find out on the upper half plane only. Okay, so for that what we can do circumference of a semicircle. What is the circumference of a circle?
2 pi r.
Okay, it is 2 pi r. Now in this case what is your r? It is 2 pi
Lambda.
Now if it is circumference of a whole circle, what will be the circumference of the semicircle?
Pi lambda.
Okay, it will be simply pi lambda. But what is given to us? The whatever the curve we are getting on the upper half plane, it is having a length L. Okay, so what will be the circumference of this semicircle? It should be exactly equal to L. Length असेल ना जे thread तुम्हाला दिलेलं correct? So in this case, what I get the value of a lambda should be equals to L upon pi. This is nothing but your radius. And hence we get the value of lambda as L upon pi and hence we get the equation of a circle in the upper half plane only with change of a thing that lambda is equals to L upon pi. Okay, so hence we are interested for the circle which lies in the upper half plane, that is we can say it is on the x-axis. So hence it is equation of a circle with minus C1 C2 as a radius and lambda is a center and lambda is a radius and value for radius we have found it is nothing but L upon pi. So this is true in case of a semicircle. Okay, any doubt?
No, ma'am.
Let me repeat the things whatever is given to us. Find the shape of a thread. We have to find out the shape of a thread of a length L which lies on the x-axis and in such a way that it should have a maximum area. Okay. So for that we have assumed that there is some curve and we have to find out that equation of a curve and it should be on the upper half plane. So hence we have considered it is from x1 to x2. Now we have to find out the integration of a that y of x, which will give you the area under the curve y of x. But what is the condition? That whatever the length we are provided, it is some constant, and hence we have imposed a new condition that is j. Now, to find out the extremization of I under the condition j, we can now use the isoperimetric problem. So for isoperimetric problem, we have integral I star by using the Lagrange's multiplier lambda and corresponding f star by using Lagrange's multiplier lambda. And after evaluating these things, we got the circle on the with center at minus C1 C2 and radius is lambda. But we are interested to find out on the x-axis and hence we have considered the semicircle. The semicircle will be on the upper half plane which is with that will be 2 pi r, that is nothing but your circumference of the circle. What will be the circumference of the semicircle? It is pi lambda, but it is exactly equal to L since the length of the thread is L and hence we can say the value of a radius will be L upon pi. Okay. Still only 5 minutes are remaining. For that, I hope you have solved the example that I have given you in the last lecture. केलेत का सॉल्व सगळ्यांनी? एक एग्जाम्पल दिलं होतं ना, y डबल डॅश स्क्वेअर मायनस वाय स्क्वेअर प्लस एक्स स्क्वेअर इज dx इज इक्वल टू 0. किती जणांनी सॉल्व केलेत? इंटिग्रेशन 0 टू पाय बाय 2 y डबल डॅश स्क्वेअर मायनस वाय स्क्वेअर प्लस एक्स स्क्वेअर dx. Subject to the condition y of 0 is 1, y dash of 0 is 0, y of pi by 2 is 0, y dash of pi by 2 is 1. I think I have given you solution also. Simply you have to put up the condition and you have to find out the values of those constants C1, C2, C3, C4. केलेत का?
Yes, ma'am.
What is the answer? What are the values of C1, C2, C3, C4? You haven't solved, please solve it once again. Okay, now you can.
मॅम
Ah,
मॅम C2च्या व्हॅल्यू फाइंड करता येईल
आन्सर सांगते का? हा मॅम चुकले
करा ना
म्हणजे
ऍटलिस्ट.
त्यात पुटअप केल्यावर व्हॅल्यू
पुटअप केल्यावर व्हॅल्यू मिळत नाही का?
येस मॅम.
Have you tried it with the Cramer's rule? Try it once again, otherwise I will give the answer. Or unless otherwise, if wherever you are, जहाँ आप अटक रहे हो वो मुझे PDF करके डाल दो कि हमको यहाँ से सॉल्व करने नहीं आ रहा है. So at that time I can help. Okay.
ओके मॅम.
Okay. Now you can leave the meeting and you can join the next lecture. Thank you.
मॅम हॅलो हॅलो मॅम